Hi everyone, I am Nikhil Lokhande from CSCIA, roll number 60, PRN number 1231127 and today we will be talking about transaction management in database management systems. Transactions ensure data integrity and consistency during database management operations. So, what are the basic transaction concepts? Definition. What does transaction mean? Transaction means set of operations to perform logical work. What are operations? Operations read and write the data in the database. What is an example of a basic transaction? A bank transfer between two accounts. Let us suppose I have to send money to some account. So that transaction of sending money from my account to someone else's account uh, is a transaction. So the money from my account will first get deducted. It will get credited into someone else's account. That is a basic example of a transaction. What are asset properties? We all have learned about asset properties. So asset properties mainly consist of four things. A, C, I, D. A for atomicity, C for consistency, I for isolation, and D for durability. What does atomicity mean? Atomicity means the all or nothing execution of transactions. So basically, atomicity means the if a transaction is getting placed, it will happen as a whole. So if either the whole transaction will happen or no transaction will happen. Consistency. What does consistency mean? Consistency means database remains in consistent state. The database must be consistent before and after the transaction. The database must be consistent as in before and after doing a transaction. The whole database should not get affected by the transaction in any ways. Just it should get affected by just the changes done by the transaction itself, but it should not affect in any other ways to the whole transaction. Isolation. Transactions execute without interference. So when we are talking about a database management system, a lot of things take place at the same time. So uh, it is really hard for transactions not to affect each other. So each and every transaction should work on its own and it should not be affecting any other transaction and it should not be dependent on any other transaction. Each and every transaction in the whole database management system should be independent to itself and should be should occur without any interference. Durability. So durability stands for committed changes are permanent. So whenever we make a change in a transaction, it remains permanent. It is not temporary. The changes of a successful transactions occur even if the system fail occurs. So what does that mean? The changes of a successful transaction occur even if the system failure occurs. Let us suppose you are part of database management system and the system fails. So the changes of a successful transaction they remain constant and even after that we recover the database management system, the changes which we have done successfully in the transaction, they are reflected even after the recovery. Let us move forward. So our next slide is about transaction states. So let us understand what are transaction states. There are multiple transaction states. So first is active. Active transaction state means the transaction is being executed. So active transaction state means the transaction is working in place and it is getting executed. It is still in the process and the transaction has not completed yet. It has started, but the transaction has not ended. Second, partially committed. All operations executed in local memory. So in partially committed transaction state, all the operations which get executed They occur in the local memory and are not are not reflected on the whole database management system server, and they don't affect the whole server yet. They occur uh, they occur locally, and the next one is failed. So uh, as we all know, failed transactions means the transactions that do not get completed normally. So in failed transactions are transactions which we which we make which we try to complete but do not get completed, and there are some abnormalities shown after the transaction gets completed. The fourth one is aborted. So transactions rolled back, changes undone. So when you roll back a transaction or when you undone some changes which you have done, so that means the transaction is aborted. Committed. Transaction successfully completed, change is permanent. When the transaction is successfully committed, and when you do not undo the changes, when the changes are permanent, then that is known as the committed transaction state. Let us move forward to schedules. So there are various states in schedules. Let us talk about all of them. Serial schedule. Transactions execute completely one after another. Non-serial schedules. So operations of multiple transactions intervene. And strict schedule. Right operations precede conflicting operations of other transactions. So let us understand each one of them. We will go by one. We will go one by one. So serial schedule. In schedule, transactions execute completely one after another. Operations of multiple transactions in non-serial schedule. Operations of multiple transactions are intervened. So in serial schedule, each transaction is getting executed one by one after another. And in non-serial schedule, a lot of transactions are getting intervened at the same time. So non-serial schedule is mostly like trees. It is how trees work. So strict schedule, right operations precede conflicting operations of other transactions. Let us move forward to serializability. So let to understand what serializability is, we should go and we should go to learn what's the definition of it. So serializability is equivalent to serial execution of transactions. So serializability means keep executing the transactions serially one by one. So what is the conflict serializability? It means non-conflicting operations can be swapped. So swapping non-conflicting operations is allowed in conflict serializability. What is view? View equivalent to serial schedule. View is equivalent to serial schedule. In serializability. Yeah. Let us understand about concurrency control protocols. So what are concurrency control protocols? The first one is lock-based. Transactions acquire lock or on data items. Two-phase locking. Growing and shrinking phases for lock acquisition. Timestamp based. Uses system time to order conflicting operations. Validation based. Uses updates local copies. Validates before submitting. These are some concurrency control protocols. Let us understand some lock-based protocols. Binary locks. Lock or unlock state. These have only two states, locked or unlocked. Shared lock. It is read only, multiple transactions can hold. Exclusive lock. Read, write, only one transaction can. It is exclusive to only one transaction. What is two-phase locking protocol? There are in two-phase locking protocol, there is a growing phase in which transactions obtain locks and cannot release any lock. Lock point. Transaction holds maximum number of locks. Shrinking phase. Uh, as you can see, this is the lock point and this is the acquired locks. This is shrinking phase going downwards and this is the growing phase. So in shrinking phase, transactions release locks and cannot obtain new ones. What are recovery techniques? So few of the recovery techniques are system lock. So system lock records transaction operations for recovery. It keeps a log of all the transactions happening for purpose of recovery. Checkpointing, establishing consistent states for faster recovery. So putting checkpoints uh, in your transactions so that the recovery process can be faster, and you have to recover only to the checkpoint, not to the whole transaction. Undo and redo operations. Reverse or reapply the transaction effects and shadow paging. Shadow paging basically means using shadow copies for atomic updates. So using shadow copies, so basically your system will atomically update. And this was my presentation. Thank you.